Welcome back, pre-algebra. We're in lesson 40 today. We're going to talk a little bit about reciprocals. So a reciprocal is reciprocal. A reciprocal is the inverse of a number. So it is the inverse. It is, if I had a fraction 2 over 5, then the inverse or the reciprocal of that would be 5 over 2. We just flip it, right? We just flip that fraction around. And the reciprocal of a whole number, say we have 4, we could turn any whole number into a fraction by giving it a denominator of 1. So the inverse of a whole number would be 1 over that whole number. Now we can do the reciprocal of any number except 0. Because 0 over 1, if 0 is a whole number, 0 over 1, the value is still 0, right? So we can't flip this at all. You can't put 1 over 0 because this becomes indeterminate. So we can only do whole numbers and fractions with a reciprocal. So let's say we had 16. The reciprocal of 16 would be 1 over 16. And let's say we had 3/10. The reciprocal of 3/10 would be 10 over 3. Okay? So it's pretty straightforward, and it's very, very easy to understand what that means. The hardest part about it is remembering that a whole number can be turned into a fraction by putting it over 1. And all that means is if you took 16 and divided it by 1, you would still get 16, right? So that is why we can put any whole number over 1 without changing its value. All right, let me clear the page, and we're going to talk about the multiplication and division rule for equations. Okay, so whenever we have, let's say we have a any kind of equation, let's say we have 4 times x is equal to 16, okay? In order to figure out, remember when we had addition and subtraction, what we would do, we would always do the opposite. So if we had 3 plus x was equal to 5, this is a positive, or let me rephrase that. We had x plus 3 is equal to 5. This was a positive 3. What we would do the opposite operation. So we would subtract 3 because subtraction is the opposite of addition. Well, multiplication and division have that same relationship. Division is the opposite of multiplication. So here I have the whole number 4 and the x. 4 times x. Whenever you see a whole number and a variable next to each other, that means multiplication. So 4 times x is equal to 16. So we have to undo that multiplication. So what we're going to do is divide both sides by the number we know, which is 4. We don't know x, so we can't divide it by x. But we know 4, so we're going to divide this side by 4 to get rid of that factor times x. But if we do it to this side, we have to do it to this side as well. So 4 divided by 4, any number over itself is 1, right? So that becomes a 1x. Well, when we write 1x, typically what we do is we drop the 1. My dog is giving me a hard time right now. He keeps bumping my hand, trying to get me to pet him. 16 divided by 4 is going to be 4. So what we can do is we can check our work, and we can go back to the original equation. 4 times x is equal to 16, and take the value we found for 4 and substitute it in. Actually, I'm going to write it in a way that you're used to it. 4 times 4 is equal to 16. We know that 4 times 4 is 16, and 16 is equal to 16, so that checks, and this is the correct response. So let me give you the multiplication and division rule for equations. Roscoe, stop bumping my hand. So here we have the multiplication and division rules, and notice they're numbered 3 and 4 because the addition and subtraction were numbered 1 and 2. Both sides of an equation can be multiplied by the same number without changing the solution. Number 4, both sides of an equation can be divided by the same number without changing the solution. So let's do some more practice problems. Let's start with 40.1. So here we have, in 40.1, we have 4x is equal to 12. Okay, so we know that 4x is 4 times x. So the opposite operation from multiplication is division. So we're going to divide both sides by 4. Right? 4's cancel. 4 divided by 4 is 1. So that's going to be an x left by itself here. And 12 divided by 4 is 3. So now we can use this and check. 4 times 3 equals 12. We know that 4 times 3 is 12, so we know that this is a balanced equation and 3 is the correct solution. So let's do 40.2. In 40.2, we have some fractions. So it looks difficult, but it's really not. So a fraction here, when we have this fraction, this is a division problem, 2 divided by 3, right? But at the same time, it's being multiplied by y. So it's really 2 times y divided by 3. But we split the fraction off of it. And what we've got to do is figure out how to multiply by the number we're dividing by and divide by the number we're multiplying by. So what we do is we use the reciprocal fraction. So what we're going to do is we're going to multiply by 3 over 2, right? And I know y'all are used to seeing this little X right here. The dot is also used. And what happens when you do that is you get 3 times 2 is 6. 2 times 3 is 6y. Well, remember, whatever we do to this side, we have to do to this side. So we're going to multiply by the same reciprocal over here, 3 over 2. So 6 over 6, that's just 1. So it's really just y by itself, right? So, but now we're going to multiply this side by the reciprocal because we have to do the same thing on both sides to keep this equal sign true and to not change the solution. So 1 times 3 is 3, and 5 times 2 is 10. So the answer to y is 3 over 10. So let's check it and see. So the original equation was 2 over 3 times y is equal to 1 over 5. So let's put in the value of y. 2 over 3 times, and I'm going to use multiplication parenthesis here just because it's easier for fractions. And this is another way to write multiplication is with the parenthesis. So 2 times 3 is going to be 6, and then that's going to be over 3 times 10, which is 30, right? This is the original value. 6 over 30, if you divide 6 by 6, you get 1. And if you divide 30 by 6, you get 5. So you can reduce 6 over 30 to 1 over 5. So this checks. This is the correct answer. Okay? Let's look at 40.3, see what else we can do. So 40.3 says we have m over 3 is equal to 6. Okay, so this is kind of difficult looking, right? We have Our variable is being divided by 3 to get 6. What is the opposite operation to division? It's multiplication. So when your variable is being divided by a number, we're just going to multiply the whole thing on both sides by the denominator, because that is the opposite of being divided by that number. So 3 here and 3 here. 3 times m is 3m. 3m over 3, that 3 over 3, that's 1. So those two really just cancel each other out, and we're left with m is equal to 6 times 3, which is 18. So let's put this back into this equation and see what we have. We originally had m over 3 is equal to 6. Well, if I put 18 in where the m is, 18 divided by 3 is 6, and that checks. So now you see how to solve these types of problems. When you have a fraction and the variable is one of the parts, you're just going to multiply when you divide when it starts off as multiplying, and if you have a fraction times a variable is both multiplication and division. So we flip it so that we can multiply and divide by the opposite number. We use the reciprocal fraction times the fraction with the variable. Okay, let's do one more like that, because I feel like we need one more, just one more practice. So if we have, here's 40.4, we have 1/3 x is equal to 9. So what we have to do is figure out what x is, right? So we're going to multiply by the reciprocal here. So I'm going to multiply both sides by 3 over 1. And it's really easy to turn a whole number into a fraction by just putting it over 1. We've already talked about that. But 3 times 1 would be 3, and 1 times 3 is 3 times x. 3 over 3 is just 1, so that goes away. So you have x by itself. 9 times 3 is 27. 1 times 1 is 1. 27 over 1 is just the whole number 1. That's 27. So x is 27. If we put that back in the original equation, 1 over 3 times 27 is equal to 9. So that would be, we put this over 1, that'd be 27 over 3. 27 divided by 3 does indeed equal 9. So this is the correct value for x. Okay? All right, so we've talked about the division rule for equations. Both sides of the equation can be divided by the same number except 0 without changing the solution to the equation. So let me clear the page. And we're going to do 40.5. And this says 4x is equal to 3. Of course, we could solve this equation by multiplying both sides by 1/4, right? Because we have 4 over 1, right? We could easily do that, not a problem. But we could just as easily divide. It's the same thing. But when we do that, we get 4 over 4 is 1, so we have an x left behind. And then our answer is just going to be the fraction 3/4. Now, if you want to check that answer, we could just substitute in 4 times 3/4 is equal to 3. Now, this would be 4 over 1 because it's a whole number. 4 times 3 is 12 over 4. 12 divided by 4 is indeed 3. So we know that 3/4 is the correct value of x. All right, let's do one more. Let's do 40.6. So that is going to be n times 0.04 is equal to 28. Do not let this throw you for a loop at all. Do not let it bother you. Because we have multiplication here, what we're going to do is we're going to divide both sides by what we know, and that is going to be the 0.04. So when we divide, we get that 0.04 cancels. So all we have left over here is n. N is equal to 28 divided by 0.04, which is going to be 700. So if we substituted this in, for this n was 700, 700 times 0.04 would be 28. So our solution checks. All right, I can illustrate that for you. We just put 700 in here times 0.04, and that would equal 28. And I'll just go ahead and show you. We'll just do it just for funsies. 0.04, that'd be 0, 0, 28, and then 3 zeros. All right, now we're in this place value, 3 zeros. Bring everything down. And we have 2 decimal places, 1, 2. This would go away, and our remainder, our value would be 28. So it does check. All right, so those are all the possible ways to undo an operation and separate what we know from what we don't know, so that we can solve for what we don't know with multiplication and division. So try out these when you do your practice problems, and really think about and make sure you have your example problems in front of you so that you know how to undo and do the steps for each of these. And that's all I have for lesson 40. I'll see you in lesson 41.